People that are working. Okay, so we learned that the area under the curve is what is represented when we did the integral. Okay, but sometimes we've only been able to do shapes that we know the area formula for. So what were some of the examples we did yesterday? We did rectangles, we did trapezoids, triangles, we also had,
Yeah, we did a half.
we did a semicircle.
We did the like half trapezoid.
Right, we took a trapezoid. So if we know the formula for the area, we can find integrals that way. But what if it's a parabola or another shape that doesn't necessarily follow a
And you just
specific
don't do
formula? We do it. We do. Yeah, no, we don't just say not possible. So these rules for definite integrals I want to look at first, and then you'll see it jumps to 6.2. I just used formulas that they teach you later, and I introduced them in chapter 5. So let me just show you a couple of these rules that you do need to just memorize. Okay. The first one is if you have the normally an integral, oops, that's annoying. Normally an integral would go from the lower bound to the upper bound, but if these are opposite, right, if the bigger number is on the bottom, then we change it to a negative and we can switch them.
Always.
Always. So just a quick example.
Like opposite or
So if I have like, let's say it's 3:1 of f of x dx, I could switch this around and go from 1 to 3 of f of x dx.
So you won't.
So you basically just switch them. You always want the bottom number to be lower. That's the key. You want the bottom number to be smaller. So if it's not, then we're just going to switch them around and make it equal. All right, next one is 0. Well, next, if we have the lower bound and the upper bound are the same, think about what would be the area under the curve. Yeah, we can't have an area because it would have no width, like it wouldn't have any dimension to it. So that's going to be 0.
If the lower and upper bound are the same.
Yeah. It's like finding the area under the curve from 0 to 0. It's 0. Or from 1 to 1. It hasn't, remember the bounds tell you from here to here, but if your second bound is the same as the first, you haven't gone anywhere. So it would be 0.
But what if you want to know later? Is there a possibility that there's an integral and then step 2 integral?
No, it's just that when the bounds are the same. Okay. Next one. Constant multiple. So if we just have a coefficient out in front, we can put it outside the integral. That's all. Sum and difference. So the integral can be, if you want to think of it, distributed. So if there's a plus or a minus sign in between, you could distribute the integral to both parts.
So
And then-
multiplication.
Yeah, so it just means like if I have a function, let's just say, for example, from 0 to 1 of x squared plus 3x. You can just break it up into x squared. No, okay, you'll see when we get down here, it's just one way of making, so when you want to go take the integral of something, if you can factor out a constant, if you can bring the constant out in front, it might make it easier. Or sometimes, in order to integrate x squared plus 3x, maybe it's easier for you to think of doing the integral of x squared and then the integral of 3x. And actually this 3, we could use the constant multiple and put it out in front. We don't always have to do that, it might break it down into something simpler. Additivity. Okay, so this one is basically two integrals where the first bound, so the first integral, the upper bound, is the same as the second one's lower bound. It's almost like transitive property. It goes from A to B and then from B to C, so we could combine it all into one from A to C.
But what do you do about the
Oh, here, well, let me just, it helps to kind of look at a picture of this. Let's just say I have a graph. And here's A, here's B, and here's C. So if I'm considering the integral, I'm looking at the area under the curve. So would you agree that the area under the curve from A to B, oops, I forgot, right, plus the area from B to C is equal to the whole thing? That's all. The f of x is just whatever function I'm using.
Can you give an example with the numbers? Oh, I
It's
see.
like
The
a
f of x would be the same. I'm sorry. I get it now. Never mind.
Wait,
You
what
got
if it, but I, no, it's, like, what if there's two different, what if, like,
I won't
what if,
scroll.
the F, what if, like, that was, like, a different,
They have to be, okay.
It has to be the same.
They have to be the same.
Okay.
This has to be
Right,
all
okay,
f of
that's
x.
what I was-
So it can't be something different. In the, in the one above, these are different functions, so you can distribute it. But you can't use this rule with two different functions. It has to be the whole, has to be the same function over the whole thing. It just means that you can either take two smaller parts and make it equal to the big one, or let's say you have a big from A to C, you can break it up into two parts.
We do examples of this.
With real numbers?
We won't do an example. We do A. I think that would.
That's the plan.
Yeah.
So, okay, this unfortunately is not very, if you're visual, this isn't really helpful, but maybe you can think of this in terms of you have a function, from function f, from -1 to 1, the area under the curve is equal to 5. That's what the integral represents. Okay, so we have some function, we don't know what it looks like. The area under the curve just from -1 to 1 is equal to 5. And then the same function from 1 to 4 is equal to -2. Now what does that mean if it ends up being negative? Do you remember?
That you
The
switch
graph, well no, I mean just
Graph
in,
goes below
the
the
graph goes
x-axis.
below the x-axis. And
So
then
how could this be differentiated between when it goes below and when
we don't know for sure where. So this could technically have maybe part of the graph is above, but there's more of the graph below. We don't know. We just know the whole thing ends up being negative. And then from -1 to 1 of another function, h of x is equal to 7. So the area under this other curve h is equal to 7. Now I have to just warn you, some of these are not possible. So you have to kind of think about, just given this information and the rules that we can apply above, what would each one of these quantities be equal to? So the first one, you should notice that the lower bound is not smaller.
Define the negative.
So we can just flip it. So the very first one we looked at, the very first rule in that table was flipping. I'm just reminding you that the integral represents the area under the curve.
Wait, then can you just plug it in your
Yeah,
calculator?
so here, what is this whole thing equal to? It's equal to -2. This whole thing here is negative, so we have negative 2, which makes it a positive 2.
Will you plug it in the calculator? It's negative something, but. That's what it is.
Possibly.
Wait.
This whole thing in the table, or this information, we know that from 1 to 4 of f of x dx is equal to -2. So when I pull the negative out in front, you have negative negative, so that makes it positive.
So, is the next one's
Okay.
answer 3?
So the next one,
Yes? No?
okay, that's a different, we shouldn't be using, we don't need to use our calculators for these. So this is -1 to 4. So I already know the area from -1 to 1, and I know the area from 1 to 4. So can I put those two results together? Yeah, so that's how I'm going to rewrite it. I want -1 to 1 of f of x dx, and then from 1 to 4. What allows us to separate it into that? That was the very last one, the additivity. Why did I do that? Because I don't have enough information. I don't know what -1 to 4 is up here, but I know -1 to 1. Yeah, you shouldn't need a calculator for any of these. So you have from -1 to 1, that's equal to 5. And you have from 1 to 4, which is -2. So when you add them, you get 3.
Yes.
Okay, next one is -1 to 1 of f of x plus h of x. So this one is the second to the last one, rule, where you can distribute the integral. So that's going to be from -1 to 1 of f of x dx plus -1 to 1 of h of x dx. So the first part is, what's -1 to 1 of f of x? 5. And what -1 to 1 of h of x? So we get 12. That was the second to the last one. That was this sum and difference. Okay, so D, take a look
that's
from
hard.
0 to 1 of f of x.
You can't do that.
Can we do that? There's not enough information. There's nothing that we could do to try to break this up that would give us a 0 to 1. You might first think, okay, well, if from -1 to 1 is 5, maybe from 0 to 1 would be half of that. But not necessarily. We don't know what f of x looks like. The only way we'd know that is if this is symmetric, if this would be a symmetric function.
Is there a
So-
way to plug in backwards to find out what f of x is?
And yeah.
Do it.
If we know,
If we knew the function, then we could figure it out.
no. If we know is there a complicated way to find the function if you have the definite integral and the high to low? Is there like a method?
There's not enough information here.
No.
There will be information. I'll show you how to work backwards, but we need more information, no matter what. We would need a graph, or just giving values isn't enough information. Okay, how about from -2 to 2 of h of x? You can't do that either. And how about the last one? So the last one is kind of a combination of the constant multiple and what we did in part C. So we can pull the 3. Guys.
Hey. It wasn't part of the first 2 periods.
All right, any questions on?
What are the typical of the ones that we just did? Are these all really easy?
These are relatively easy. Okay. Lauren, girl. What's the question? No, the 3 is only part of the f of x. If the 3 was out in front of the bracket, then we would pull it. Then it would get multiplied to everything.
Oh.
And this is both,
Awesome. Thank you.
No. Which ones are these? The sum and
This is the sum and
addition?
difference and the constant multiple. You don't have to be able to name them, just know how to apply them.
we'll wait till you talk about
Are we skipping 6.2 because these are the shortcuts?
Okay, so I'm jumping ahead to 6.2. The only thing, guys, shh. Do I have to make a seating chart for you guys? Seriously. I think that might be a good idea.
Lauren's been behaving.
So from 6.2, we jump ahead, as I was saying, we were jumping ahead to get the formulas for chapter 5 because for whatever reason, this book just introduces all the formulas later. When we did derivatives, okay, so just for example, when we would do derivative, actually let me do x squared. Okay, so let's just say f of x is equal to x squared. So when we would do the derivative, it would be 2x, right? Okay, so what I'm trying to do is I want to show you how we work backwards. So let's say we are given 2x and we want to get x squared. So when we work backwards, first of all, we use just the capital letter F represents the antiderivative of what's inside. Okay. So these are all antiderivative formulas. And one of the things I want to show you guys, can you stop talking? Okay. Indefinite integrals are a little different than the definite integrals we had above. Definite integrals mean you have bounds. You have numbers, like here's -2, here's 2. Those are what we call definite integrals. Indefinite, the bounds are missing. Okay, so we don't know where it starts and where it stops. So the way that we kind of handle this is that we give it a result, but we put on this plus c at the end. That's what we call that the constant of integration. So what you end up with here, this is a formula. And the formulas that we have are just below here. So what I want to do is say, let's say I start with f prime of x equals 2x. How do I work backwards to get to the x squared? All right, so here's how we work backwards. They're not bad, don't worry.
I understood the method of the trig formulas because they were just the opposite of the derivatives that we learned.
Okay, these are all what we learned before. So this is the first one, is the power formula, and this is what Maytal was saying. So this is probably the most important one. Okay, so an example of this would be, let's look at that last one, where I had 2x.
It's not x squared.
Okay, no, I'm going to work backwards to get x squared.
How do you know when?
Well, so what I do is I take, this power is a 1. Okay, so whatever this is, it's to some power. What do? We add 1 to the exponent. Just leave the coefficient just stays there, just like when we had derivatives, it just automatically gets multiplied. So it becomes 2x. We increase the exponent by 1. And then we divide. Notice it was an n plus 1 here and an n plus 1 here. We divide by that same exponent. Plus c. So these, whenever you have the bounds missing, you need to add plus c at the end. Well, what happens to the 2's? We just get x squared. The x squared is the important part, but you always want to include the plus c in your answer. So I could do this for any power. So if I gave you let's say the integral of x to the 5th dx. What would you get? You would get x to the 6th over 6.
Ooh.
What's 5 plus 1? 6 over 6. Could you do it if you had a 1/2 power?
Yes.
Okay, what would be 1/2 plus 1?
3 halves.
3 halves. Divided by 3 halves.
Or it would just be 2x
Or it
over
would just
3.
be 2/3 x to the 3 halves plus c. So anytime you have the integral, just add 1 to the exponent, divide by that same exponent. That's it. Add 1 to the exponent, divide. Remember what you did for derivative? You moved the exponent to the front and subtracted 1. So here we're moving, instead of multiplying it, right? That's what you did with derivatives. You took the power and you multiplied it to the front and took 1 away from the exponent. Now we're dividing
On the
and
practice,
adding 1.
on the practice of the last chapter, me and Emmy and Lauren were trying to figure out like this one problem. We realized that it was the point on the function because we couldn't figure out how to find the x, so we did like antiderivative, not like realizing when we realized
Working.
for the x.
Right. And that some of you were thinking along those lines with the other problems. And said, well, that's when we get to antiderivatives where you actually work backwards. Now this only,
If it gets
oh, the only time this power rule does not work is if you get -1. What happens if you have a -1 power?
goes on the
You
wall.
get 0 in the denominator. So that's our only exception to the rule. And that is right here. And that's the ln. Well, think about that. What's the derivative for ln? 1 over. So the antiderivative for 1 over would be ln. Notice there's absolute value. We just always have to make sure logarithms are taken up positive numbers.
You repeat that. So when do you repeat that one?
Anytime it's a real number and not -1.
So this one, it would be like negative x, right? Or is it be the antiderivative of x to the -1?
This would be the antiderivative of x to the -1.
Yeah.
Okay, so these are just working. The next ones, if you can remember the derivative, hopefully you can figure out the antiderivative. Because they're just, like for example, what's the derivative for sine? It's cosine. So the antiderivative for cosine is sine. What's the derivative for tangent? It's secant squared. So the antiderivative for secant squared is tangent. You see that?
Yeah.
So, actually those, so these are the 3 main ones that, it'd be good to, I mean, I want you to know all 3, or all 6 I should say, but obviously sine, cosine, and the antiderivative for secant squared are going to be the ones that show up the most, because those involve sine, cosine, tangent. Chapter 5, I will tell you in advance, Chapter 5 is the whole test will be calculator okay. And one of your classmates in the AP class found a formula program that they downloaded on their calculator, so you could see if they would be willing to share it. It just has like all Ishai.
Is that what you tried to?
Yeah, he sent it to me and then I helped him put it on his calculator.
There's no
I'm really
link.
sorry.
There's no link thing for
Does it work
calculators.
for
Can't we just try it?
You talk to Ben.
Does he have it?
He has a Casio.
But does he have the programs?
No, he's finally, he says he's gonna get a TI Inspire. I
My
don't-
mom just won't give me one because I lose them.
Oh.
Have you lost this one?
But you
Oh,
said,
no, I haven't lost this one
all
yet. I
right,
lost my last one.
a couple more and then let's do some examples.
You lost your black one?
This one, does this one make sense?
Your black
Oh, I
one?
lost it.
Derivative of e to the x is e to the x, so the antiderivative for e to the x is e to the x. I'm not gonna highlight these, not that they're not important, but I won't test you on them. I only highlighted ones that you should know for a test or a quiz. So I will definitely, you might see them in the homework, but you can just, you can highlight all of them. I guess I was highlighting specifically ones that you need to know for a test or a quiz. So the other three, if they will come up in the homework, but you can just look at your notes.
So all 6 of those will show?
All 6 of those are kind of fair game for a test, but I just told you the test was all calculator okay, and there's somebody that has all the formulas in a program. So
That
if you
sounds
can
so-
figure out how to access that. Okay, let's do some examples. These are fun.
Wait, what if on a new calculator or was it on his old calculator? You know,
It's on the old calculator, but he shared it with like half the class.
Right, but like this, like he doesn't have, like he'll need.
No, but half the class. So there
Oh,
are other
all the-
people that
okay.
had him transfer it to their computer. It's a program that just, when you click on it, it lists all the derivatives and all the antiderivatives and has all the formulas.
Oh, so really fun.
But you just need to know, you need to know how to apply them.
Can I just bring in? I have a question. If I don't download that and it's in my calculator, can I just bring like a little note card that just has them? Can we do like the same thing?
Let me think about that.
Yeah?
Yeah.
Okay,
Yes.
I said, let me think about it.
I think the answer should be yes.
All right. X squared,
X to the third over 3.
x to the third over 3. And because this does not have any bounds, it's plus c.
None
Do you
of it.
understand why I need to, so this is saying what's the area under the curve for x squared? Well, it's infinite, right? It would go on forever. So we're saying the area under the curve is going to follow this formula, x cubed over 3 plus c. So we'll talk about that plus c when we get to chapter 6.
Yeah, do we
But
ever
right-
find C?
We will. We will find c.
What is?
Okay, part B. The 2 can go in front.
2 sin x. 2, yeah.
Oh, that doesn't look like an x.
Nope. It's like a fish.
It does. That'll bother me. Okay. All right.
That's a shark.
Plus c. Don't forget the plus c. E to the x. E to the x.
Oh my god. So this is.
Okay, so now we just need to do, these are all power rules, even the last one. If you look at the 4, think of this as 4x to the 0. So when you have a constant, it would end up being just 4x, basically. Okay, so we end up with
What do you do with the 2?
2x to the
Oh, you
4th
just keep it?
over 4 minus 3x squared over 3 plus 8x, sorry.
Right, the antiderivative of our-
No, once you do the antiderivative, once you find the formula, you're done.
Could you simplify? I
Yeah,
simplified.
okay, so I want you to simplify. I just wanted to show you that the coefficients, just kind of bring those coefficients along and then see if something can simplify after you've integrated. Once you increase each of these exponents by 1 and divide, you don't need that little s in front of big S. It's eliminated. We've taken the integral. Now just simplify any fraction. So we get 1/2 or x to the 4th over 2 minus x cubed plus 4x squared plus 4x plus c.
I'm kind of confused what integral means.
Integral means.
Is it the antiderivative? Is it the same thing?
Okay, so when I use the term antiderivative and integral, they're the same thing.
They're the same thing.
Yeah.
It's like
When I
slope
say
and derivative.
find the
Like
antiderivative,
area under the curve.
they all mean the same thing.
Wait, so the area under the curve is the antiderivative.
Yes.
But is
Okay.
it
The curve is the derivative because it's a slope, obviously. That just makes
Obviously.
The antiderivative, guys, when I say find the antiderivative, usually I'm looking for, like, what is the formula that we get? But the integral, when I say the integral, I'm referring to the whole thing.
So pretty much whatever.
But it's
problem
all
you-
the same.
Whatever problem you give us, we just have to find the antiderivative.
Right, so for all of these, what did I say in the directions? Evaluate the
Wait,
integral?
What about the triangle and the?
Yeah, then the
Oh, find each indefinite integral. Well, how do you do that? By finding the antiderivative of each part.
Oh, so indefinite integral is antiderivative, but like if you're given the two numbers, you have to do.
That's a definite integral. Indefinite,
So definite, you have to do the other way, but indefinite is just finding the antiderivative.
right.
Okay.
Okay, so here we get 3e to the x plus 2x to the 5th over 5. Let's see. Does anybody want to do f?
Plus.
When there's no
Bounds.
when there's no bound.
Okay, so David, could you
What do you make the half? What do you make? Oh.
Yeah. Anytime you see a radical, rewrite it so it is a rational exponent. So if it's square root of x, rewrite it so it's x to the 1/2. So we get, again, this will be to the first, so 6x squared over 2. And then if I take half and add 1, it becomes 1.5, or 3 halves. Over 3 halves.
Oh,
So we get 3x squared plus, well, that's just the reciprocal, right? When we divide by 3 halves.
yeah, it's minus.
Oh, I forgot my minus. X to the 3 halves plus c. Yes.
G
Huh?
not
There's a
not
number
able to
decimal.
be solved.
You tell me if it's in this interval.
-1 over -1, so that's just negative x.
It goes from 1/2 to 1.
It's x to the -1.
Yeah.
Okay. Oh, did anybody figure out G?
Yeah.
What do you get?
-1 over x plus.
Okay, so x to the -1 over -1 plus c. So it's just -1 over f plus c.
Do you want us to simplify it like that?
Yeah. If you end up with a negative exponent, please just rewrite it so that it's in the denominator, because that's technically simplified form. We don't want to leave like x to the -2. Even though I gave you x to the -2, I could have written it as the integral of 1 over x squared, but it helps to think of it as x to the -2 and then do the power rule. Integral of negative sine x. So here's where you just have to be careful about positive and negatives, because the integral for sine
It's positive cosine.
was negative cosine, so this would be like a negative cosine.
Wait. Oh.
So it becomes positive cosine.
Why? Because it's the derivative.
The antiderivative, here if we go above, see that right here? The integral for sine is negative cosine. So it's like a double negative, which makes it positive.
So just because that's cosine.
Yeah. How about, somebody want to give me I?
Yeah, I got root of x plus c.
Okay, so we ended up with, let me just write it out. So you ended up with basically adding 1, you get x to the 1/3 over 1/3
Yeah.
plus c. So we get x plus 3. I'm okay if you leave it as 1/3 or if you want to write it as a cube root. Either way would be fine. As long as it's not negative, because if it were negative, I'd want you to make a fraction out of it.
So the next one, I thought was the hardest.
Okay, the next one has a coefficient. If you don't like working with the 4, remember you can always move the 4 out in front and integrate it first. So I could rewrite that as x to the 1/2. So just figure out what that is, which I think we've done twice now. So 4. And then this would be x to the 3 halves over 3 halves.
That's going to be 8 over 3 times 8 over 3 x plus 3.
So it becomes 4 times 2/3, right? X to the 3 halves, so it just becomes 8/3. There's nothing you could do with that. Just leave it.
Those are fun. I like those.
Yeah, I like
Did you
Oh,
like
5.3 continue. Wow.
Yeah,
that was
yeah,
it.
yeah,
Is this
yeah.
the last?
No, we have 5/4, and
5,
then
4, and that's it.
This isn't until tomorrow.
Wait, don't we have a take-home quiz? No, no, no.
yeah, you have a take-home quiz
Not
that
tomorrow.
will be.
Yeah,
On the
the
19th.
continued is on the 18th.
February?
Wait.
So it's tomorrow.
Yeah, tomorrow.
We don't have it.
Wait, on the 18th.
I meant that we were gonna.
We have class tomorrow.
No, we don't.
No, we don't. We don't have class tomorrow.
Yeah.
Okay.
We're fine.
Okay.
We're
We're all
done?
good.
We're done.
The class is over.
So, yeah.
So let's chill.
So let's do homework.
Stories,
Let's
stories for
watch
us?
Winter
Yeah, let's do the homework.
Homework. Alexis, great idea.